Okay, welcome back to another college algebra video. This is section 2.5, transformations of functions. And in our class we do this out of order. If you're watching this from a different class, then you obviously watch it whenever you want. It's still 2.5, but in our textbook we do it after section 3.1. Anyway, we're not going to cover everything in this section. We'll do most of it. This is transformation of functions. You need to know the graphs of common functions, and you need to be able to use vertical shifts, horizontal shifts, and reflections. We're not going to do the vertical and horizontal stretching, and then you've got to be able to put these together in a sequence of transformations. Do more than one at a time, in other words. Okay. But the first thing you need to know is the basic graph for about 8 common functions. So the first common function is the constant function, f of x equals c, and then there's the straight line function, absolute value function, parabola, square function, square root function, cube function, and the cube root function. These 7, I said 8 earlier, but 7 graphs you need to know. The f of x equals a constant c graph is known as the constant function. The range is 1 point. It's a horizontal line, and the domain of the function is all real numbers, and the function is constant on all those real numbers. F of x equal x is known as the identity function. It is a straight line. We've already done a bunch of stuff on straight lines, so I'm not too worried about you handling this function because you should be able to graph straight lines. The absolute value function is sometimes called the v function. The v function is 2 straight lines coming together to form a v. The domain is all real numbers. The range is non-negative numbers from 0, including 0, to infinity. The function goes down to 0, 0, and then comes back up. All these functions here from this one on go through the origin, and that's going to be kind of our important point to get our graph started. X squared, your basic quadratic function, it gives you a parabola, and this parabola has a vertex at 0, 0. All real numbers is the domain once again, and the range is non-negative numbers again from 0 to infinity, including 0. The square root function is half of a parabola on its side, so it starts at 0, 0 and climbs up and starts to level off as you move to the right. The domain is non-negative and the range is non-negative numbers. X cubed is the standard cubic function. It's kind of the S function, if you will, on its side, and it goes through the point 0, 0. The domain is all real numbers and the range is also all real numbers. And then the inverse function for that is the cube root function. It's the S function on its side, like this. See the difference between the cubic that's going up and down much more steeply. This one's flattening out as you go left and right. But its domain and range is also all real numbers. Okay. So you need to know those basic functions, but obviously you can lay that out in your notebook and or put them on flashcards or whatever and have them out with you because you can use your notes. A vertical shift is when you add or subtract a number outside of the function. So you do the function first and then you add or subtract at the very end. That is why it is a vertical shift, because it is changing the y values. Y moves up and down. Okay, so for an example, if you have the absolute value of x function, what does the absolute value of x plus 3 look like? The plus 3 is outside of the graph. So this blue graph is your given f of x. That's f of x. Okay. What does g of x look like? G of x is shifted up by 3 units. All right, so what does that look like? This is this graph right here. Notice that 0, 0 comes up and gives you 0, 3 as the vertex now. That point needs to be labeled. These other 2 points were just whatever. They were just helping us get the graph down, but those are really not important compared to this one. I got to see where the vertex goes. And so 0, 0 went up 3, went up to 0, 3. Okay? Horizontal shift. Horizontal shift is when you add or subtract inside the function. So it's before you square or square root or anything like that. And here what's happening is the domain is getting changed because you're changing the x. Because we're changing the domain, it's happening before the function is evaluated. Therefore, the change affects it in the opposite direction. If I add c to an x, that means I'm adding something to the domain, which means I need less x to start with to get the same thing out. If I need less x, that's to the left. Here, if I'm subtracting c from x, I need more x to start with so I can balance out the subtraction. More x is to the right. That's why it looks like it's kind of being shifted backwards, but it's really not. It's just you have to understand what's happening. So if we start with the graph of f of x equal the square root of x, that's what this looks like here, square root of x. Here's the point 0, 0. That's the only point I really care about, is 0, 0. All right, then what happens to the graph of the square root of x minus 4? It shifts to the right 4 units. So what does that look like? This purple graph here gets shifted to the right 4 units. You go from 0, 0 to 4, 0, and that's your starting point. All right, and then everything else with the graph looks basically the same. All right, except you've been shifted over 4 units. The third possible change in your graph that we're going to focus on is a reflection. A reflection about the x-axis means the y is being changed, and so it happens outside the function. A reflection about the y-axis means the x is being changed, which means it happens inside the function. Okay, so reflections just take everything on one side and move them to the other. F of x is equal to the cube root of x. We want to look at the h of x equal to the cube root of negative x. The negative happens on the inside of the function, which means that you will be reflecting across the y-axis. All right, left to right. X's move left and right, and so you're reflecting left and right. So the graph of x, the cube root of x, is blue. It looks like this. If you reflect that for h of x about the y-axis, then this blue becomes this one, and this blue becomes that one. And so this graph right here, notice that 0, 0 doesn't move. This that I'm tracing out here, that's h of x. Okay, that's the cube root of x, cube root of the opposite of x, cube root of negative x. That's what that graph is. All right? So we want you to try to put these together. And here's the process that I want you to think about. When you plug a number in for x, what happens? Well, the first thing you would do would be add 1. So the first thing you do, if that's an add 1 inside, what kind of shift is that? That is a horizontal shift, and it's to the left 1 because it's a plus and you need less x. All right? What's this negative 2? That happens outside. We subtract 2 outside. What does that mean? And that means we go down 2. So what does x squared look like? The basics of x squared. Remember, that's your parabola graph. That starts at 0, 0. So if we go left 1 and down 2, we go left 1 and down 2, that puts my new vertex at negative 1, negative 2. All right, and so this is my f of x graph. My new graph is going to start at negative 1, 2. If we want to try and get a little bit better picture, we could plug in like 0 to get the y-intercept, and we get negative 1. All right, and so you get that. But these graphs I'm not worried about being as nice and neat as the parabola graphs were in section 3.1 for those of you that have seen that already. Right, and this is the point that I'm really interested in. Where did the vertex go? Negative 1, negative 2. All right, that's how you handle that. That's how you put them together. List them in order as if you plug a number in, and then how you would evaluate it, and then write it down, and then sketch out the new graph. So y'all try this one, pause the video, and remember what the absolute value of x graph looks like. This is your f of x graph. This is the v graph, remember? V. Make them straight as much as you can. That's your f of x graph. And so we want to find g of x. Pause the video, show me what you got. Okay, so what happens here? The first thing you do is you subtract 3 inside, and so that's to the right 3. Then this time we have something new. We have a negative out front. That happens before the plus 4. And so you have a negative outside. And so what's that? A vertical flip. That's top to bottom, bottom to top. And then the third thing you have is the plus 4 on the outside. And so that is a up 4. All right, so let's see what happens then for g of x. What happens to the vertex point? It goes right 3, and then it gets flipped upside down, and then it goes up 4. So we have this point 3, 4, but this is no longer at the bottom of the graph. This is at the top of the graph. All right, and so then we're going to have it come down and make a V shape upside down. Okay, and there's the graph for g of x. And that's all. That's what I'm looking for. I'm not looking for anything fancy. Obviously on my math lab, you're going to plug in and use the tools available to graph your stuff, but this is going to require a little bit more practice on the worksheets maybe than some of the other stuff, because my math lab doesn't do a great job of helping you learn how to do it. It just kind of lets you use their technology, and it's basically one step below plugging it in your graphing calculator, and that doesn't really help you learn it a whole lot. So you need to know these shiftings well and be able to apply them in multiple step processes like we just did. And I'm going to want to see your work. Just the answer is not enough on your quizzes and things. It never is. But in this case, really, you've got to show me every step, because I need to know where that came from. Okay? You can use your calculator to check your work, but not to do it. So I hope that helps. Let me know if you have any questions. Thanks.